Welcome, everyone. Excited to continue this speaker series for Impactful Innovators with someone who I think is really part of this groundwork of robotic automation that is going to change so many different aspects of supply chains and how the products that we have in our everyday life travel to us. So William Fosnight, class of '92. Really at the center point of this innovation area. Welcome, Bill. Thank you so much for taking the time.
Thank you, Jason. Thank you, Kelly. Thank you, everyone. Good afternoon. It's nice to be back at RPI. So what I'd like to do, I'll cover several topics today. I have a fair number of videos and pictures, and I'll try to, most importantly, maybe weave in some stories of what it's like trying to start up an automation company. I think the thing I want to emphasize, and it'll probably be a recurring theme, is thinking about your network and your reputation. So as I go through these stories, I think you'll find there's a lot of places where there's, the importance of who I've connected with and how that relationship played out that came back in life and really mattered. I have the outline here on the left. I'll talk a little bit about how we found our partner and our customer, as well as building a team, developing the technology, and talk a little bit more about business and opportunities and our vision at the end. So I'd be remiss, a lot of, our product's called Alphabot, and I have a very strong partner, John Lurt, who was the founder. I go as co-founder. It's kind of like pilot and co-pilot. But John was someone that I met, and this is already a story of networking. He hired away my best engineer in a previous company. So he wasn't my favorite guy maybe at the time, but that opened the door, and maybe it's good never to burn bridges. I followed up with John later in life, and when he was thinking about doing this startup, we reconnected. But John had been thinking about how to automate supermarkets. It was a passion he had for 25 years. And this all started in the time of 1994. So John was thinking about, well, how could we use robotics or automation to make grocery stores more efficient for the retailer as well as a better experience for the customer? And it was interesting, some of his early ideas, you would be shipped a catalog and you would have to enter your order with a dial-up modem. So that was some of the original things he talked about back then. So, this was his original concept, and this is from 2003. So John's a very innovative. He's a history major by training, but a super brilliant guy. And, he has this vision that he would lay out. So he partnered with a company called St. Ange Studio. And this was about the same time that Nick Mounts was founding Kiva Robotics, which is now Amazon Robotics. So many of you have probably seen Amazon Robotics, where they have the robots that drive on the floor and move around these racking systems. John was thinking, we probably need to do something 3D to get the density and the storage density that would be required for a grocery operation. And one thing I'll point out here is that we had ramps going up to go to the different levels, but he didn't quite know how to make those work. And the other thing was, to the right of this picture, there's robots going out to the right and left. Hadn't really worked out the density of traffic, how to get these bots all to one location for the picker. But it was a great visual and a great vision John had, as far back as 2003. He got detoured a little bit. He met some others. John's very good at networking. He met a gentleman from a CNS grocery wholesalers. They're one of the largest grocery wholesale companies. And they said, that's a really neat vision, but we need something for storing cases of products that get distributed out to grocery stores. So this is a system that John conceived where he solved the problem of going to different levels. Instead of having the bots, he didn't know how to make the bots go up and down the ramps and do that, but they came up with these kind of green and red rotating lifts that would allow the cases to get moved to the different levels for the robots to move. So this is the actual implementation then of that system. So it gives you an idea, how big of a vision is. So again, John just has this kind of animation idea, and within a few years was able to, this is the guy he hired away from me, made this a reality of doing this. So these are where they take cases of products in that are full pallets of cases from a manufacturer like Campbell's Soup or a soup company. And then they need to ship out mixed case pallets, so mixed items that go out to the grocery store, because a grocery store doesn't need a full pallet of tomato soup. They just need a case or two of tomato soup. And then here's the robot that is mixing that pallet to go out. So very successful company. And, again, I was still at my previous company, and my previous employee was doing very nice working with John on this solution. So, and John, he wanted to get back to the grocery stores and retail was his passion, and he wanted to get back. So he started over in 2011. I'd sold his interest in Case Pick, which is now Symbotic, and that's me there. We met and reconnected and started talking about, is there a way that we could really do what his original dream was, to have robotics and systems that go into grocery stores. And at the time, the idea of putting mobile robots in grocery stores, it seemed far-fetched. Most grocery stores and retailers would say, we're not going to have robots in a store for a long time. And nowadays, it's very different, that I'll talk about more. So, John, this is our rendition. I spent many Saturdays working on concepts, and the real problem we solved was how to make the robot go vertical. And by doing so, what you're seeing in the picture is, in the back, there's a blue storage structure. The blues containing all the products that you find in a grocery store. It could be bananas and mayonnaise and eggs and ketchup and everything else. And then these robots are bringing the storage tote out to the pickers. And at the same time, other robots are bringing bags or totes containing just order bags. And this is where now the picker is able to transfer from the product tote and complete and sorted into the order tote. Once the order is complete, the robots take the order back into the storage system and then ultimately deliver it to the customer. So, what you're seeing here just in these 9 locations is about 3 to 4 times the volume of most grocery stores, but it's in a footprint that's probably 1/10 the area of a grocery store. And the people that are picking in this video, they're picking between 800, or in this video, they're actually up to 1,200 items per hour. Grocery stores now have Amazon created the demand in the market for people that like to have their groceries be able to pick up or deliver to their home. So the way stores are responding to that is they hire people to go up and down the aisles, just like you do. And most people don't realize, when you go grocery shopping, you're essentially an unpaid warehouse worker going up and down the store warehouse, picking your own order. So if you're not doing it, then the store needs to hire people to do it. In the store, pickers can pick about 80 to maybe a maximum of 100 items per hour. So when you think about, most grocery orders are 40 items or so, there's at least a half hour of labor, which ends up being 10 or 15% of sales just in the picking out prospect. So it's a very tough proposition for grocers, and I think that's very much where we came in is there's a pain point now as the grocery market is evolving, and John had thought about it in advance, and maybe it's now the right time and the right place for the technology. So John met with Walmart. He was actually avoiding Walmart. We thought they would be big and nasty and try to steal all of our IP. It turned out they've been a blessing to work with, and provided development funding, and I can't say enough good things about how they've really been a collaborative partner to us. So it's funny how sometimes you think, well, that's a company that you wouldn't want to engage with, but it turned out that they've been a very good partner. A lot of this though goes back to, again, John had the vision, John had the animations, But a lot of what he needed was, well, how do you make an animation into real automation? So that's John there on the picture on the right, and our friend's Basement Joe. That's looking at how the robot would transfer the totes with the products in and out of storage shelves. So we came up with a simple chain conveyor. And then on the left is in my friend Joe Mac's garage. This is where we were showing how we can make a bot move from moving horizontally, like many robots can do, in shuttle storage systems, to then having it convert into an elevator. So, we did all this just as a hobby. This was most of my weekends driving. This was actually in Manchester, New Hampshire, we talked about earlier. I was driving from Saratoga Springs to Manchester, New Hampshire on weekends, and just so we could play on the weekends and do this type of work. Just a little bit more about Walmart. Again, networking. So John Lurt, again, I say his name a lot. He's a brilliant guy and a great partner. He had been networking with a Harvard professor in retail, and the Harvard professor was at the World Economic Forum in Davos, Switzerland, and ran into the CEO of Walmart, Doug McMillan. And Doug had said, well, we're looking for automation. We've scoured the earth looking for an automation system that's compact and reliable and low cost enough to work in a grocery store. And fortunately, the Harvard professor said, well, you really should talk to my friend John Lurt. So just a fun part of the story is they had codenamed a project named Project Alpha within Walmart, which was top secret and only known by maybe the top 10 executives within Walmart. And when John went and pitched our Project Alphabot to Walmart, the CEO kind of glared at everybody, thinking that they had leaked the project or the secret information, but just a total coincidence that we had independently developed the Alphabot that was ultimately adopted by Walmart. So that meeting was in February, and by August, in just about whatever that is, 6 months, we had reached an agreement and actually started a company. A lot of the challenge then became don't underestimate the work in building a team. So we had pre-recruited 8 people that from our network. So I'd been talking on nights and weekends and convincing along with John that this was going to be a great startup and a great thing to do. And a lot goes back to networking and your reputation, that people want to come work with you. So we pulled from our network and a relationship of about 30 years. Today we're about 190 people. And a lot of, again, credit goes to John for really, he focuses a lot on the culture. I've spent a lot of time focusing on the technology, but, making sure that we have a very a place where people love to work and want to be at work and enjoy it. Just one thing I'll mention about leveraging our experience at network. One of the reasons that Walmart had confidence in funding us was not just the technology or even that John had done it before. It was very much about convincing them that we had a team that came from an area that would bring applicable knowledge and capability. So this video that's kind of playing fast, I hope it's not too jerky, but this is inside of the Global Foundries factory they had shared on a video of inside the semiconductor factory. And, semiconductor automation is very advanced in terms of its reliability requirements, as well as just the the depth of technology and software to control their mobile robots that run on the ceiling. That was one of the things we recruited out of this industry, and I think it gave us a big head start over most automation or companies that had been trying to adapt automation. That we came in with the paradigm of, we get to shut the system down once a year, not once a day, in terms of the robustness and reliability of design. So really bringing that type of experience from another industry was very beneficial, to convincing Walmart that, we could really do things that other people can't. So this is a quick timeline. This is our startup team of 8, started up quickly. Within 6 months, we developed our first prototype of the robot. So this is where you'll see the robot move horizontally and then be able to transition into an elevator and move vertically. Just to give you an idea, the most advanced automation and kind of current state of the art automation is what's called a shuttle. And it's just a robot that goes up and down an aisle. And then when it gets off to the aisle, it has to hand the tote off to an elevator. So our whole paradigm was we wanted to build a system that was only mobile robots that would do what all these other companies have to have elevators and conveyors and a lot of other technology that Once it breaks, then it wouldn't be suitable for a grocery application, and it's too expensive. 18 months into the startup, we had a complete alpha system. So this was our first full designed integrated system. This is a video that's showing how the bots unload and load the totes and move to all the various locations. But I still find it amazing relative to John's original vision and animation, how much the real automation looks like that animation. Again, we put our first beta system in, started installing the first store 2 years in. So very proud of the fact we told Walmart executives that we would go from nothing to installing in a first store full-scale system in 2 years. Their attorney later told us that he would have lost a lot of money because he was betting against us internally being able to do it, but very proud of the fact the team was able to do it. And this is a picture of the first installation. And again, at 30 months, we've grown to about 110 people. So networking, a lot of time in interviewing people, recruiting people, because when you get to this type of size now, you're outside of your immediate network, and you really have to spend time, screening and understanding, getting the right people that both have the right knowledge and technology, but also fit your culture. This is our second system install in Arkansas. So Walmart was very pleased and presented us to this is at their analyst day where they bring in all their stock market analysts. So it was a great opportunity for us to showcase our technology and at our second installation in Arkansas. And this just gives you an idea of the full scale of the system in Salem, New Hampshire. This is a full picking system that, the robots store all the grocery products to complete the orders. But a lot of work. It's not just the robot to develop, but also the software and all this mechanical structure we had to develop as well. So talking a little bit about how we did it, again, bringing knowledge from the semiconductor industry, we knew that we would have to focus on reliability. So no matter how good or superior our technology, if it doesn't work and it's not reliable, we're never going to get out of the gate. So as a team, we made sure we gathered and pulled everybody together to think about, how are we going to prioritize? There's so much to do, and there's so many things we need to focus on. What are our priorities? So of course we said safety first. We could not hurt somebody with this type of technology. Reliability, our architecture itself is fault tolerant. And one of the things we designed in from the beginning is that with mobile robots only, if a mobile robot dies, there's always multiple paths to any location. So even if a robot is now operable, the system continues to run. And if you think about like a system with conveyors or elevators, once one of those breaks, blocks the transport of everything else. Not to mention, you have to wait for a technician to show up with a part many times to repair it. And that's what retailers like Walmart had been burnt by, waiting for hours or days to fix a system, which obviously that's not going to work in a grocery store application with customers. So these are test stands, where we did accelerated testing of our wheels and chains and gear rack, for having the bot climb. This just, I don't want to be too salesy here. This just goes through, some of the key things that they were looking for in a system. And again, for us having started from a white sheet of paper, that was really a key requirement that John and, I joined him in the last, couple of years to really study the problem, study the pain points of the grocer and, what would be required. But a lot of it came down to, density in terms of being small, density in terms of being a lot of throughput in a small area. And we achieved that by having the bots be able to move on all these stacked horizontal levels. But it also needed to be capitally efficient and not to mention work in ambient, chilled, and frozen, which ended up being quite a bit of work. Sometimes you got to think about, how you come up with these ideas. Let me go back to that. So, John had been thinking about ramps, and the only reason that we started talking about going vertical was we were filing patents. So, it's important to protect your technology, and we were writing patents on these mobile robots that could move three-dimensionally and bring the products and the order totes together. And we were at the time thinking about the bots going up and down ramps. And I said to John, I said, it's really important that we also cover, even if we don't know how to do it, we better make sure we file a patent on the bot climbing vertically, because if that's not the next logical thing somebody would try to make better. So we started thinking about it. And then I remember the movie Goldfinger. I don't know if any of you've seen James Bond Goldfinger, but he has this cool Aston Martin where the centers of the wheel hub come out, the wheel spinners come out and cut up the spy's car next to him. I thought, man, it'd be really cool if we could do something like that to where the climbing gear, the pinion gear, could come out on that same axle, because it would be a very simple design where that same motor that drives the wheel would drive our climbing pinion. And that's essentially the what was the genesis of the design. So you can see this picture now in the middle with the robot or the video, where there's a gear that extends out from the middle of the drive wheel. And so there's one direct drive servo motor on each side that drives that drive wheel. And then when we want to climb, the robot, we like to say, transforms into an elevator, where it extends out the gear. It goes into a gear rack, as well as these red wheels that engage in a channel and let it turn into an elevator. So you can kind of see on the bottom right how that's happening. The other thing we kind of do cool is not only does the pinion gears come out, but we also suck the wheels in. So this is like landing gear that, when we want to go up to these different horizontal levels, we have to suck the wheels in so the bot can move between the levels. Then when we get to the level we want to be on, we put the wheels out and sit down on that level. For me, this is just a passion. It was almost like a challenge or a hobby, and I'm very much into robotics and FIRST robotics. Going back to my RPI mechanical engineering days, it was fun to be able to apply this type of idea. The other thing I'll mention real quick is our robots don't have any batteries. Most of our competitors have batteries, and batteries are a problem because they take time to charge, as well as even in some cases they can catch fire and other things. We use ultra capacitors. So I pulled in, I said, there's a friend I have, Matt Cody. I went to a startup without him, electrical engineer, and we used ultra capacitors. The thing that are great about ultra capacitors versus batteries, they fully charge in about 15 or 20 seconds. So while we're moving vertically in these channels, you'll see in this picture in the middle, we have charge toes that come in and pick up power. So the bot is charging while it's moving vertically, which is also when it needs the most power to climb. So we never have to stop and charge. So just some fun videos of what it looks like from the bot's perspective moving through the system. So we do have 6 cameras on the bot, and as a startup and a business, we're always trying to think ahead in terms of how do we make this reliable and really robust. So these cameras are very beneficial for also debugging, like if there's an error or an issue, we can go back and check the video. But also in the future, we'll use these to remote in. So think of it almost like an underwater submarine. So if there's an issue that we can recover from a remote location, if there's a blockage or a box of cereal sticking up or something like this. Not only did we have to design the bots themselves, we had to design all the structure system that support the bots. I won't go into that too much. These are the channels where they climb. Those are the yellow rails are the electrical power rails that the bots use to pick up power. And then it's just a video. You can see the bot kind of more clearly here, how it moves horizontally on a level. This is just a system in our lab where we're testing a new structure design. And you can see how it transforms it into an elevator. And if you remember from that first video in the garage, very similar to what we're doing in the garage, just in a production bot now. So we also needed to design our own tote. One thing we do differently, we do use subtotes. Many people would say, well, why don't you just use dividers? The advantage of using these subtotes for containing groceries is this allows us to, and this is something that John had thought of, and we spent a lot of time thinking about, is you want to be able to maximize the storage density. So by using these automatable subtotes that we can pick up with a robot, we can always do defragmentation, similar to disk defragmentation on a PC, that as the totes go empty, we can pluck the empty ones out and make the storage density much denser this way. And then this is just showing the automation I was referring to, how we can move them around automatically. Probably one of the things that fouls up most startups, especially in automation of software. It's always more complex and more difficult to perfect. I like to say we cheated. So the same software that was running semiconductor factories, again through relationship, I introduced John Lurt to a gentleman named Rory Gagnon, who had a software company that was controlling the robots moving around semiconductor factories. So we were able to obtain a license to a source code and with an agreement that we would not compete in semiconductor, which of course we're in grocery, we don't care about semiconductor. So we were able to take a license to the source code, and that was a big help in advancing our capability to have a control system that would control the robots. The lines you're seeing in this model, this is the simulation, but it's basically showing the path reservations. So our system works very much like a air traffic control, where the bots are given paths where they're allowed to move and plan. And then as they go past those node points, those paths become available to be reserved for other robots. This is just a picture of a full-scale system. That's the same one I just showed in the video at the Salem system. These three aisles are all ambient. This aisle, the shorter aisle is chilled, and then the small aisle is frozen. So we had to spend a lot of time thinking about all the process and how to make it so that the bots can go between those various systems. This is just showing the real life picker at the system. So this is where on the right side are the products coming in the totes. We do a pick and put to light, and then the picker picks from the tote and places. So another thing, back to safety, we had to put a lot of evaluation in how to make this interface safe for the associate. I probably spend as much time thinking about how to engineer safety solutions as anything else with a system like this. It's important as you think about a startup. It's kind of easy to think about the happy path, but the work is really within all the exception cases and all the what ifs. And DuPont has something called the what if analysis. We spend a lot of time using what if as well as FAMIAs, the failure mode effects analysis, where you're thinking about what are all the possible failure modes, and then ranking them for severity, likelihood of occurrence, and detectability, and then using that to prioritize your work. A lot of work has to go into that. Of course, I'm sure some of you are thinking, well, wow, that's a really crappy job having to transfer those products constantly at those kind of rates. It's a natural extension of our technology that we are now integrating robots that can do that pick and put capability. Arms aren't as fast as people. We tested people can go as high as 1,500 items per hour. Robots today can do 400 to 600, but then it becomes a more of a business case of, well, how do you maximize the value? So what you might want to think about is that during peak periods where you have to do a lot of orders fast, you use humans. But then in the off hours, you can, especially where you have orders that are ordered ahead, you can use robots that just plug away, on a more continuous basis. I mean, there's a lot of business thought that has to go into a startup like this, modeling as well as just the pure technology. This just gives some more statistics on the deploying and scaling. One of the key challenges we have now, these are big systems, big automation systems, and for these customers like Walmart, one of the challenges that you think about is how do we scale fast enough? So one thing, the hardest part was 2 years, proving the technology works and these robots can climb and do all the stuff we promised. But a company like Walmart, you have to be able to scale pretty quickly because their business is such a large scale that unless you can fulfill a significant need of their stores, or it becomes not of interest to them. I'll let you think about that, and I'll tell you in a minute, like one of the ways we're doing that. This is just a video of the actual store up in Salem, New Hampshire. I think I'll skip this one in the sake of time, but this is just, again, how the robots pick up and drop off. So, again, Walmart's been a very good partner to us. Again, John was avoiding them in the beginning, and we were concerned about them wanting to steal our IP, but in the end, they've been a great partner to us. It's hard to not say enough good things about them in terms of their willingness to collaborate. We were doing pretty good and pretty happy to have Walmart's business, but now COVID, it's a terrible way to get attention. but it certainly is driving the business in this area. So sometimes I guess it's just a matter of being in the right place at the right time. We kind of felt we were in the right place in the right time to getting the acceptance of robots in the grocery and this idea of micro fulfillment centers where now the automation's at the store level. So you can see in this chart that online grocery is one of the fastest of all growing, especially now with COVID, how it's changing the environment. One of the other things, I guess, too, is don't underestimate how quickly markets evolve. John had it in part of his initial vision that not only would we pick the orders, but we would have the ability for the robots to drive out of the building and then go down and deliver to these types of pickup portals. We thought this would be 3 or 4 years down the road. We're now deploying these and starting to do this now. The market changes very quickly, and it's a challenge to keep up with this type of opportunity. So, getting a little bit to how do we scale fast enough? So, some of the challenges of a startup are, well, you need cash and you need the ability to scale. So, another relationship I had in my life was with a company, Muratech of Japan, who I've also been amazed by their capabilities, their engineering and manufacturing. So we reached out to them and said, look, we've designed this robot for grocery, but it really could compete with anything in the storage and retrieval systems very effectively. So we were able to grant a license, an IP license, which helped us with cash in the short term. I think more importantly, we've thought about this at a bigger level that now we can collaborate. So our new structure and even our new robot version we're putting out is being done in conjunction with Murata, who has about 6,000 employees and 1,000 engineers. This is definitely helping our ability to scale for Walmart. Along with, we did have to select partners like Plexus, who's one of the largest contract manufacturers, that we can turn out many of these robots. So in the order of thousands of robots at a time to satisfy the demand of the retailer. I have talked a lot about Walmart today. That we're not. I just want to clarify. We're not exclusive to them. They don't own any equity in the company. They've just been but that we do. We are very committed to making them successful because they did provide the initial funding and support of our company. And finally, I think it's important, John, getting back to his long-term vision. It's very much that we have our eye on the ultimate store in the future. So when you go to a grocery store, essentially that whole center store is all the canned goods and all the packaged goods. And one jar of peanut butter is like any other jar of peanut butter, and one can of soup is like any other. John's vision is that we automate all that, but we want to preserve the market for the fresh goods. So many people still enjoy coming to the market to pick their own steak or pick their own vegetables or fruit. So this is our vision for the store of the future. Today, most grocery stores on the order of 80,000 square feet or more. So this is on a footprint, it's about a quarter of the space. What's novel about this to really disrupt the market, and it's something you have to think about, is how are you going to disrupt the market, is that we have a much better operating cost than a traditional grocery store, the way this operates. But there's also a lower capital cost, and it's very unusual to have a scenario where you have a lower operating cost and a lower capital cost. And at the same time, you're making the customer's life better. There's a lot of thought that needs to go into of what problem are you solving, how is it really differentiated, and what are the economics behind it. So I think in this case, I think that's why Walmart realized that this type of solution where you automate at the store level was the answer, because you get all three. You get the better customer experience, you have lower operating cost and lower initial cost. I guess the things to walk away with from this whole story were a lot of this was purely, following something I wanted to do, and innovation, something I'm very interested in, robotics. I love robotics and inventing stuff, but every bit as much as it is about the technology, it was about the relationships. My relationship I had with John, that could have been one that, well, he's my enemy for life because he hired my best engineer away, but kept an open mind and turned out to be the best partner a person could have. It's about all the people throughout my career in semiconductor that were willing to come and work with me again. We could really pull the right team together. So that was very important. As a startup, there's nothing better, I don't think, of having someone that's willing to invest in your company that's also a customer. So obviously they had a vested interest in supporting us and making us successful. So that was a very key point. Building a company that's just a great place to work. So we're very focused on culture. We have very many nice policies. I won't try to do recruiting, I guess, on here now, but we have very many nice perks and benefits and policies where it's a great place to work. But we really hire people that love their work, want to work with others. So with that, I'll stop and open it up to questions.
All right. Well, thank you so much, Bill. I really appreciate this. This was great. I love those videos. It's amazing to hear how the kind of vision and the animation as a way of selling the future, and then really led to building the future. So, but we'll start with questions from the students. We'll start with Adi.
So, what principles from semiconductor automation were most applicable for your product, other than like the license you got for the software?
That's a great question. A lot of it was around reliability. They were designed for reliability. Things like simple things, even like flex cables. Having designed robotics in semiconductor and automation, anytime a cable is flexing, it tends to break and wear out, and it's one of the highest failing components in a robot. So this robot, we said we're not going to have any flex cables. Well, we ended up with one. A lot of it was knowledge that people brought about designing, board-mounted circuits and things where we could compress and minimize connectors. But it's also, I think, just a mindset, a mindset of how to build a reliability budget. And, so I think a lot of people don't think enough maybe about reliability up front. They think, well, I'm going to build the product, I'm going to make it work, and then over time, I will try to figure out how to make it more reliable and reliable enough. We started out with, the design has to be fault proof, fault tolerant, minimal number of motors, very robust, and did a lot of modeling of our reliability allocation model, it's called, where you go through and say, what is the probability of everything failing, multiply it together. And then when you do, you say, oh crap, that's not good enough. So it needs to be better yet for these components. So we borrowed a lot of that experience from semiconductor.
Perfect. Thank you. Thank you, Bill. That was an amazing story. How hard of a process was developing the prototype? Like, were there deadlines given to you by Walmart? I know you talked about like that 24-month period that you gave yourself.
It's gotten harder as we get larger. In the garage, there was no pressure. We didn't have Walmart back then, so it was just fun. We were doing it for the Miller Lite and the recreation. But we learned some really valuable things in the garage. We originally were doing like a 4-chain mechanism where we had to line up 4 chains for 4 wheels that would climb together. And then we're like, well, this is a pain in the butt trying to line up all 4 chains. What if we just did 2 and cantilevered it? By doing that prototyping kind of non-risk, it really took some of the pressure off, because when we got into the actual development time frame, we knew what were the key risks that we had to evaluate. So there was a little bit less pressure. But there was still uncertainty. One of the big uncertainties was noise. So these robots climbing these gear racks in this cantilever, they make kind of a grinding noise, but we did a lot of development to where you can barely hear them now. But there were nights I lost sleep where, the lady from Walmart showed up and you could hear a robot running in our lab probably 200 feet away. And she's like, I don't know if that's going to be quiet enough to really get installed in a store. So, sometimes that drove the drive, and was it necessity is the mother of innovation, I think it is. There were times where we felt a lot of pressure. John and I and some of our engineering team, we laid out what we called the 2676 plan. 2 months of just getting ourselves together and assembled and our requirements. 6 months of kind of design and prototyping. A 7-month design phase, and then a 6-month alpha. Going up to the ready to deploy in the store. Just one other thing to share is that we were close to doing a deal before Walmart with a big grocery chain, and one of the largest in Germany. And John and I were really bummed out when that fell through. And it was a matter of mostly when it went to their board in Germany. This is another thing, it's not always technology. They decided, well, it would be preferred to work with a German automation company than an American automation company. And sometimes, nationalism and other things play into it. It's not just your technology. So we were really bummed out. But the cool thing was that was before we had developed this type of simple cantilever design. We were still doing a pretty complex 4-axis or 4-chain design. So now in retrospect, that was a blessing that we got that delay, and we would never have met Walmart if that had happened. So sometimes you get these setbacks in your startup and setbacks in life, but in retrospect, they can be absolute blessings as well.
Walmart deals with many fresh products. How does the system accommodate expired produce?
Yeah, two ways. One option is they can pick fresh from the store and still maintain that. And then we induct the tote into our system. So we do the storage and consolidation. So when you look at the grocery business, the picking is one aspect, but there's also the cost of storing and there's a big cost of dispensing to the customer, which we also automate. You can do the produce from the store, but in most cases now, what's done is the fresh goods are put in packages and inducted into our system, and then it's picked the same way out of our system. One of the big benefits, I guess, is an important thing to talk about from a business standpoint. I've talked about the labor efficiency. The other big benefits of a system like this are really the digitalization of the store. So today, grocers really don't know what's on their shelf. So if you're competing with Amazon and all the I don't know mushroom soup has been picked off your shelf, or there's not as many cans as you thought, you get into what are called substitutions. And most grocers have, for fulfilling online grocery from a store, they have as much as a 10% or more substitution rate, where they don't really have what they're selling on their website. So inventory accuracy is very important and a big value a system like this brings, as well as when we induct all the products into the system, we know the expiration dates, which they are not able to track on shelves. So we actually have an advantage that through our database that we share, obviously, with Walmart or any retailer, we can manage that expiration and push systems out of the product or offer sales or do other things with the data because we have an accurate inventory count. So we always have better than 99% inventory accuracy in our system, whereas most grocery stores report account accuracy less than 50% of what they have in their store.
Where's the type of store? What's the type of location that this technology really fits? I can imagine it being having some type of sweet spot, but I'm not sure what that sweet spot would be. Maybe is it very large stores that have already built up a large inventory of online orders, or is it kind of mid-market places that Walmart is really not fulfilling many orders and could grow a smaller footprint store like you put out in the future?
One opportunity is grocery stores will decide they're going to build what's a fulfillment center for just doing online grocery orders. And these are typically 40 or $50 million facilities that they invest separate from their store. Well, the problem with that model is you're investing 40 or $50 million in this big distribution center. And then what you're doing is you're cannibalizing the sales of your actual grocery store. So as people shift to online, now there's less people shopping in your store and you decrease your income. So now the stores become less profitable. And then what do? But now you have to make a decision. I'm going to shut those stores down. Walmart was the first retailer we believe who recognized the answer to this was not to build fulfillment centers in addition to their store, but to put the fulfillment center in the store. So that first video I showed, because we were new and it was kind of innovative, they built space on the side of an existing store for us to house our system inside of it. And that is a model that some grocery stores and some people can do. But the real win, again, is to minimize capital and take part of the existing store space. So that's what we're doing now is as more customers are shifting online, is we're taking a small area of the store, building a micro fulfillment center so that you don't have a big capital investment. And that's one of the key capabilities of this technology. So really any grocery store, we usually can find space to put a system in that can do this type of automated storage and picking.
Have you guys raised money when you started this thing? You bootstrap it all on your own, or how do you do that, or just rely on Walmart money?
Yeah, it's mostly it's all bootstrap. So we're 100% employee owned. There's no outside owned equity whatsoever. So we're very proud of that. We've been able to sell based on future values and gift cards that we sell to our customers for the sale of future systems. So we're very proud. That's probably a whole business case in itself. And John's a great negotiator. We work together, but it's been very cool that we've been able to maintain all the equity inside the company. And it was one of the things that we said to Walmart from the beginning: you really can't own equity, because if you do, no other grocery store or retailer is going to want to buy from us.
Very cool. So entrepreneurs out there, you really just need one customer. That's all you really need. So
This really was a case where, Walmart needed a solution, we needed funding. We put our heads together and it works out for both of us. We are able to sell to other retailers. I focused on making Walmart successful first because they've been so good to us.
Yeah, I was just wondering. So, like, other than the German company that you were talking about earlier, are there any companies that you've been aiming to sell your product to recently?
So, we're very focused on grocery and retail, and I think that's an important thing to know your focus, know your market. This product was really developed specifically for the grocery market, which is growing extremely fast. That was one of the reasons that we licensed the technology to Muratech of Japan. Muratech, they're the fourth or fifth largest automation company in the world. So they are now taking this in. So I didn't mention, but they were very pleased. They recently announced the sale of a system to Alpen Group. So Alpen Group is the largest sporting goods distributor in Japan. So we'll be looking for more opportunities like that, where we can license this mobile robot storage retrieval system because, again, it's superior to any of these systems that have lifts and elevators and conveyors that are more expensive and break. We're essentially a lot like the Amazon robotics system, except three-dimensional. So, we're a lot faster, we're a lot more compact than what Amazon uses. So, anything in e-commerce or even storage retrieval, we believe. I don't want to sound arrogant, but I'm very proud of it. I think we have the best storage retrieval system technology, and we're really trying to maximize the value of that. But again, we can't lose focus on our core market. So it's it's one of these challenges where we're very focused on grocery. We're going to make our presence there, but then we're thinking of ways to license the technology or other opportunities outside of grocery.
there's one last question I need to ask. If you were a freshman at Rensselaer today, what do you think you would be working on? What challenge do you think you'd be fascinated about?
I think some of it is thinking about where I'm going to make a difference in the world, where there's opportunities. So, that's something that from the very beginning I didn't talk about this. I think it's one of the things that maybe has made me an innovator or an entrepreneur. Is even when I worked most of my career inside of large companies like IBM, you saw that video where now they use these plastic boxes to move the semiconductor wafers around semiconductor factories. Early on, even though it wasn't really related to my job, I was designing the clean rooms where they have all the particle-free rooms. And a few of us, friends were talking to each other and said, this seems crazy. Why are we trying to keep the whole room clean when all you care about is the area immediately around those wafers? And we started developing the technology of the plastic box that the wafers are stored and moved from process tool to process tool, isolated from all the outer room contamination. I think it's that drive to thinking about how can I change an industry, how can I change the world. That from the very beginning, has been part of me, and that's something I'd encourage everybody to think about. Where's a niche? Where can I make a difference? And now, that's how all these semiconductor factories are run. And really, what enabled automation was these boxes that could be moved around. Before then, the operators, like the old Intel commercials, carried around the tray of wafers that were very delicate. So now they're moved around a box, which ultimately enabled automation, which is how I got into automation. Again, yes, thinking about what you want to change and be passionate about.
Excellent. Well, thank you very much, Bill, and we'll see you next week.
Again, thank you, everyone.